Say to me, clarify? How am I going to write all this under week 7 for the test? It's like I'm answering the test itself. Okay, let's just put a shorter version. Let's put the things you're going to need, a list, smaller version. So let's say for week 7, this is just what you do. Week 7, okay? Week 7, I've shown you the graphs and stuff, but for week 7, what you're just going to put is, for E is IR, okay? It's IR plus IR, okay? This is it. And you know that this IR is actually the delta V, the terminal voltage, okay? And then here is the power loss, is the voltage drop due to internal resistance, this other one. Now, if we have for E, then we're going to have for maximum charge, Q is CE. Then if I have for maximum charge, then what else do I need? Well, we're going to have for power generated, IE, and your E will be this. So you can first find E and then multiply by I, or you can just replace E here, and we know that E is IR plus, so it's like you're saying power is equal to I, this first I, multiplying E, which we know E is IR plus IR. So this would just lead you to saying now power is equal to I squared R plus I squared small r. Okay, that's another one. For power generated, it is just going to be equal to IE, or you can say it's I squared R plus I squared small r. This is going to be for power generated. This is power generated. Okay? Then when you talk about the power delivered to your device, a component, is going to be power is going to be delta VI. This is going to be the power delivered. Okay? We're talking about the power delivered to our device. Right? Good. Then if I have this for power, so I have E, I have Q, I have 2 for power, then I'm going to just have that one which says delta V battery, if we are dealing with 1 circuit, which is a resistor, a capacitor, and a source, okay? And run to apply. And we say delta V battery plus the delta V of the resistor plus the delta V of the capacitor. This should give me 0. We can apply that loop to just one loop. If it's a circuit with only one loop, and it's like that. Now, we know that the delta V battery is just our E, the EMF. Here's the delta VR resistor is going to be delta VR. We said it is always going to be a negative. So it's a negative IR. That is for 1 circuit, please, when you have only 1 circuit. Okay, one loop. Now, delta VC, we said again here, you find it as a drop. So it's going to be, you can say delta VC is equal to negative Q over C, where Q is the charge and C is the capacitance in farads. Okay, then now, once you have this, these two for delta VR and delta VC, after your 2 P's, okay, after your 2 P's, you do this one, and from this one, you get your delta VR and your delta VC. Then now you just put the charging and discharging, and you're done. For charging, it's going to be small q, the charge in the capacitor is going to be the maximum, multiplying 1 minus e to the negative t over tau. 1 minus. This is for charging of your capacitor. This is the equation when we are dealing with charging. When we are dealing with discharging, it's just q is going to be the maximum charge, then e to the negative t over tau. There is no 1 minus. This is going to be for discharging. This is going to be for discharging. Okay? Now, once I have this, then finally, I'm going to have the last one, which says tau, which is the time constant, is equal to RC. And remember that tau should be in seconds. It's time, and you'd be done. So these are the ones you're going to put under week 7. That's what you're going to do here with your pencil. And once you have them, you're going to answer any question without really having to think. Okay? Without having to think. That's the good thing about this. You don't have to think. Once you have this, all you have to do is apply them. Let's go through questions and let's see how it goes. Okay? We're going to now go through questions from tutorials, lecture slides, whatever it is. Goodbye for now.